Welcome to this presentation. Today I'll talk about this investigation titled by Energy Design and Experimental Evaluation of an Industrial Burner to Natural Gas. This investigation was made by the researchers Freddy Rojas Chavez, Fernando Jimenez Ugarte, and myself, Luis Eduardo Napan. Over the last few years, there has been a progressive increase in the consumption of fossil fuels, up to an approximate 80% of this according to the International Energy Agency. This has directly affected that in Peru, there is a high demand for domestic stoves, that the most useful are LPG and natural gas. So it's important to know the problem is focused on the high levels of contaminations that Peru has due to emission of pollutions. The Peruvian market today offers different types of cookers with different type of burners. However, the characteristic of the power delivered by the stoves through the fuels used are not specified. So this represents a kind of problem because we don't know how much is the power supply, no? And the consumption of the food. The industrial kitchens that are offered here in Peru, in the Peruvian market, have low thermal efficiency. It's like 40%, 50%, that it's approximately, or less efficient, and this is not indicated in their technical data. This can be seen in the yellow color of the flame due to the bad combustion that forms as a result consume more food than it should be, no? So it's important to focus in that problem. So for that reason, we made its investigation with the objectives of design and made an experimental evaluation of an industrial burner, a new industrial burner design, and operating of pressure to 23 millibars based on improving thermal efficiency with variation in geometric parameters. So we made out a normal geometric of an industrial burner. So it's a new design. So in this picture we can see a scan of test carried out on the test bench. So in the lower part we can see the burner. This is the burner. And this is the burner head, the mixer, and there was the injector. No, the injector with the full supply. So this was the load height, and the pot. No, and this pot had 32 centimeters of diameter, according to the norm. No, so that's it. For the investigation, the norm NTE INEN 2259 2013 was used to calculate the thermal efficiency. This is an Equatorian norm, no? So this is the constants we have to use in the test bench, no? This is all the values of the variables. As you can see, the mass, no, the water mass that we used was 11.4, no, kilograms. So in this picture, we can see the scan of the test bench in the laboratory, no. So this is this is the third part burner. So this is the first part, the second part, and the third part, no. This is the mixer, you know, the mixer and the injector. The first injector, the second, and the third one. In this case, we can see the flow meter. So because this is the fuel, no, the fuel, and this is the pressure regulator, no. to have a pressure of 23 millibar, no? Each injector. That's it. So at the first step we have the injector design, no? We had to set the power value. It was 10 kilowatts. And the lower calorific value, it was we use natural gas, no? It's a constant. And with the boat, we could calculate the mass flow of the fuel gas. For the development of the injector design calculation, it was made on the paper Diseño y evaluación de mezcladores de un quemador doméstico usando gas líquido de petróleo, ¿no? And you can find it in the bibliography of the paper, no? So in the last part, we have the injector area, and using the circulus area, we can calculate the injector diameter. This investigation involves the combustion process, so that's why we made the stoichiometric analyze with the natural gas, no? So using 10% of excess air, we can obtain this stoichiometric balance. No, that's in the case of the natural gas. The last part also was important to know the relationship air-fuel volumetric, no? So using the recommendation of the biogas stop design by Dr. David Fulford, we can calculate this using the 50% of the total air required, no? And the diameter of the Venturi tie mixers, the Len Venturi, was determined by the pre-formula, no? We can see in this part, no? All of this calculation was for the mixer design. So finally, we use the book of Natural Gas Engineer and Safety Challenge, which is a kind of derivative from the brick formula, for the burner head design. No? We can calculate it, the flame port with the formula, and the area, and the number of holes that the burner needs. No? So we can to put the value of the 1.5 millimeters as the diameter of the hole, and with that we can calculate the number of holes. No? This is for the final design. Well, this is the results of the investigation. And we can see in this table the preliminary test results. Well, this is preliminary because we couldn't continue with the investigation because the pandemic situation, no? By the way, we have this preliminary test result, no? There was 8 tests. The thermal efficiency was in average to 30%, that it's low efficiency, but the power it's a higher power burner, so that it's in the value of 10 kilowatts. No, that's why the efficiency is lower. So in this picture we can see the variation, no, of thermal efficiency per each injector diameter, no? That it's a 1 millimeter, 1.1, 1.2, and so on. For what's the difference? Because this is when the low height, remember the low height, it's the height between the pot and the burner, no? The height it was 40 millimeters. The height here was 30 millimeters. No? That is the difference, the variation of the thermal efficiency. Well, the conclusions. That it's important to mention that exists a relationship between the thermal efficiency and the burner power. Because the higher the burner power, the lower is thermal efficiency. And that fact is important because if we want to increase the thermal efficiency, it's necessary to work with cooking burners that have lower power. As a result of that, the efficiency would be higher. And with higher efficiency, we can obtain lower gas emissions and better combustion because the air-fuel mixture will be the best. About the condition of the test, the diameter of the pot was 32 centimeters. It was because the norm said that, no? And the thermal efficiency is more constant when the loading height is 30 millimeters, no? Also, the thermal efficiency is more in 2%, no? And that was it. We thank to the Dirección de Gestión de la Investigación, the True Competitive Basic and Applied Research Project, ID 707 DGI of the Pontificia Universidad Católica Perú, founded their research. No? Thank you for your attention.